I think I've almost completed functions, isn't it? Right? Completed all. I think a small part is remaining. So we'll discuss about graphs, specifically graphs, right? Something what you have not seen. I think while people are joining in, we can try this. A simple graph, say f of x equal to x. How does this graph look like, and what is it you get? Simple one, which you have already seen. The same as y equal
Straight
to
line.
x.
Straight line, sir.
Straight line, right? Straight line. So, any more specifications about this? What kind of straight line this is?
Tilted at 45 degrees.
Ah, yeah.
Passes through the origin.
Passes through the origin. Okay, that's a good point. And it makes 45 degrees. Okay, it's not accepting to pass the origin. Let's try. Probably have to draw another line. Let's see. Yeah, this is better. So it passes to origin, and this angle is 45 degrees, right? Let me do one change. If you're not sure about this, please take values, right? You can just plot. So when x is 1, y is 1. When x is 2, y is 2, so on, right? Let me just admit these people. Okay. So when x is 0, y is 0. So these are the points you get. So if you simply join those points, you're going to get a straight line. These are standard integer values I've taken. What will happen if I take, instead of this, f of x is equal to x plus 1? What will happen? Is it same? How will the graph look like?
No,
Yeah, it's not same.
it will be inclined towards the x-axis. Y-axis.
Is it inclined towards the y-axis?
I think
Yes.
like it'll be 1 unit up above the x-axis.
So you're saying it will be a straight line again, which will be just 1 unit upwards. Like this
No,
will
sir.
be,
Yeah.
yeah. Okay. Yes, Amit. Oh, this is wrong. You're saying, right? So what would be your line? What do you say? What do you feel the line would be?
No, it's correct, sir. That's correct.
That's correct. Okay, fine. So you're saying the line would shift 1 unit upwards. That's right. Okay. What about if f of x is x minus 1?
1 unit
1
downward.
unit down.
1 unit downwards. Okay. So we need not just randomly guess this. If you have a doubt, you can always draw the straight line again, right? Just take some points again, try to plot it. You're going to get the same thing. When x is 0, you can see this is minus 1. When x is 1, this is 1 comma 0. Similarly, you can plot other points and you join them, you'll get a straight line again. So we added 1 unit, it just got shifted 1 unit upwards. Okay. We just want to see whether it is true. Anyways, what happens if f of x is say equal to 2x? Say 2x. Now what happens to the curve or the straight line?
The line will be a bit more steeper.
Steeper. Okay. Steeper in what sense? You can take steeper in either sense, I think.
It will make greater angle from the x-axis.
It will make greater angle from x-axis. Okay, that's being more specific. Okay. Now, do all agree? So you can just plot rough number of points, I think. 2 or 3, because it's a straight line. We all know this is a straight line, correct? Do we know this or not?
Yeah.
So how do we know this? In justification, or which are anything I write is a straight line, or there is some specification? What is it?
The formula for straight line is mx plus c, right?
Mx plus c. Okay. Let me just note it down. You're saying if y is equal to mx plus c, this is a straight line. This is what you're saying.
Yeah.
Okay. Well, I have some doubts here. I'll just go. What if the line is ax plus by plus c? Is this a straight line?
Yeah, might.
Might be. Okay. Anybody says this is a
It will
straight
be
It is a
minus. It
It
will
is
be
a-
minus a minus c by b.
minus a minus b by. Okay. Anybody else? Anybody else can confirm this is a straight line or not a straight line? Swasti, what do you think? You can
Sir,
speak.
it's a straight line, sir.
Straight line. Okay.
Yeah.
Okay. Why do you think it's a straight line? He said y equal to mx plus c, and I've written something different, right? Why still a straight line?
We could rearrange this equation.
Okay, we can rearrange this equation. That's it. That's why. Can you tell me
Yeah.
how?
If we bring the ax and the c part to the RHS,
Okay. So this is by is equal to minus ax, so minus c. So you're saying y, if I divide by b, it is minus a by bx. So minus c by
yeah,
b. Okay. So it's similar to that form. Okay. Instead of this, what if I have, say, y equal to m square x plus c square? Is this also a straight line? Is this also a straight line?
It is a straight line.
It is a straight line. Okay. Yeah. Anybody else? No, if you feel it's a straight line, you can tell it's a straight line. If you feel it's not a straight line, you can tell it's not a straight line. It's fine. We'll see why it is and if it's right, if it's wrong. But you should have some opinion, right? Whatever. Siri, is this a straight line?
It is a straight line because m square will take some value and it will end up getting in the same form y is equal to mx plus.
Okay, so what is the definition for a straight line? Like, so because you said it is in this form, right? It should be in this form, correct? So I just changed something there, but you're saying it's a straight line. Even if I write like this, it's a straight line. Even if I write like this, it's a straight line. So what do you think is a basic condition to be a straight line? What it should be?
And c are constants.
M and C are constants. Yeah. I have assumed that M and C are constants. I'm just assuming that y and x are only variables. Okay, let me be more specific. I think I'm not clear. What about y square equal to mx plus c? Is this a straight line? No. So why no? Why did you directly say no?
because the equation is linear in.
No, that's all I'm waiting for, right? So I was waiting for you to tell me that any linear equation would be a straight line. Right. So it's nothing specific about this form. These are different forms we can write the equation, right? Nothing specific about these, right? So what we need is it to be a linear equation. So the degree of this x and y should be 1, right? Then it will be a straight line. Fine. So we all agree. So whatever I'm writing here are certainly a straight line. So no confusion there. Okay. So what will happen to 2x? So you're saying it will be closer to y-axis, or the angle made by the x-axis will be greater than 45 degrees, right? Fine. Okay. Do we know the angle? I'm just trying to. Do we know what the angle is? Any idea? No? Okay.
Yeah,
Yes,
like
sir.
we can get sine theta equals to 2.
Sine theta equal to 2. How do you
Yeah.
get that?
Because the what do you say that the slope is 2. That means for every 2 units in the y-axis, we move 1 unit in the x-axis.
Fine. Agreed. But why is sine theta equal to 2? That part I didn't get.
Because like sine will be the angle from.
Yeah.
Oh wait, no, it's not sine.
It's
not
tan theta.
Tan.
Tan theta, yeah. Tan theta equal to 2, I would have agreed. That's why I was shocked when you said sine theta. Yeah, tan theta is nothing but your slope, right? It's nothing but your slope. M equal to tan theta will be a slope. So one way to find out slope is the difference in y divided by difference in x, right? For the points. You usually for a straight line, what you do is you draw these points, right? So this, so okay, it's not straight, it should be straight. You can try to draw straight. Okay. So the difference here divided by the difference here. This is how you calculate slope. In other words, what you're doing is you're finding tan theta, opposite divided by adjacent, right? So that is nothing but tan theta. Okay. Fine. So if I write your equation as say x by 2, I just want to see if it's clear what will happen to the graph. That's all. Right. So if you have x by 2, so the curve now will be closer to x-axis, something like this, right? Something like this. The angle will be smaller than 45 degrees. Is it fine? This much is clear, right? So I can add 1 unit to this. Again, I can shift the graph. So it's easier to imagine. These are simple numbers. Obviously, when I have, say, complicated numbers like, say, 10x by 3 and plus, say something like 100 square and all, we won't imagine that in terms of graphs, correct? They're huge numbers. But when you have simple numbers like +1, +2 and all, it's easier to imagine in the graph, right? That's why I'm giving it here. So we know about straight lines. So let's try this. One more graph which I wanted you to draw. F of x equal to x square. Can you try to plot this? Y equal to x square or f of x equal to x square. How does this look? Okay. Everybody knows it's a parable. Okay. Did you get the graph? Take some values again. There's no rule that you have to do something. So what is it? 0 when x is 0, y is 0. Right? When x is 1, y is 1. When x is 2, y is 4. Just taking for negative numbers, when x is -1, y is still 1. When x is -2, y is 4. If I take 3, it will go 9. So let us try to plot these points first. So one point is say 0, 0. Next at 1, it is actually 1. So somewhere here. At 2, it is actually 4. So something like this, right? Now you may ask, why is this not a straight line, right? So this is a curl or something like this, right? So you can draw it smoother if you want. Okay? So those are not straight lines joining them. Okay, higher degree equation. Fine. So my question now is, if I add 1, if you know this is a parabola, if I add 1, what will happen? Right. If I subtract 1, will the same thing happen? What happened to straight line? Will the same thing happen? Even if something similar happens, what happens if I, instead of adding 1 outside, if I add 1 inside, what will happen? Can you draw on the same graph and tell me what will happen for each of these cases, right? So if I add 1 outside, if I add 1 inside, what will happen exactly? So you can, whenever such kind of graphs are given, very close to x square, right? Instead of drawing the entire graph, probably you can just guess from what you have to do using x square. So that's why I'm doing. So shifting, just adding simple numbers. So how does it shift, or does it shift? After that, we can again look at f of x, say equal to 2x square, right? So what will happen? That's all. Now let us think. See, there we just try to plot. Let us think what will happen. So see, this is a graph. Okay, whatever, this is x square. This is x square. Right? Whatever value I get of x square, if I add 1 outside, don't you think the graph will shift 1 upwards? Right. So what I'm saying is y is equal to, it was x square before. Now for each and every value, I'm just adding 1. Don't you think each point will shift by 1 unit? Right. It makes sense, correct? We need not think it differently. It clearly makes sense. I'm adding something outside. For each and every point I'm adding, so entire graph, yes, it will shift, right? It will shift 1 upward. So if I just have to draw the graph, let us have a better curve. Yes, something like this. Let me just delete this one and draw a smoother curve. Okay. Should pass the origin, so something like this, yes. Right, so it's just shifting 1 unit. So let me just, so the same curve, what will happen? For the same curve, it will shift down 1 unit, right? It's not that smooth. I think probably it should be something like this, right? it should be 1 unit distance in every point, right? So it's not that smooth. Okay. Have to draw a different curve. Okay, you get the idea, anyways. Yeah, something like this. Okay. So now what will happen if I have x plus 1 whole square inside? What do you think will happen? We'll come to 2x square later. We'll come to 2x square later. Now let us look at what will happen for x plus 1 whole square, this part. Shift 1 to the left. Okay. Left or right now?
Left.
Left. Okay. So saying this curve here, right? Let me try to. Not able to select. Okay. So what will happen is this, you can see this point, right? At x equal to 0, it was 0. Now, if I keep it here, it should be 0 at x equal to 1. But when I put x equal to 1, I'm getting 2 square. So actually what happens is it will be 0 when x equal to minus 1. So this point is, say, x equal to minus 1. Let me just write it down. So this is minus 1. So at 0, it was 0. Now you see that when I put x equal to minus 1, this will be 0. When I put x equal to, say, 0, it will be 1. So you can see that the graph has shifted 1 unit to the left. Okay. Okay. So you can obviously, you need not remember this. You can simply directly plot this, but it is better to imagine what happens with the graph if I add 1 unit inside, outside, and so on. This is same for any curve. So why I'm telling you for specific curves is, suppose you have f of x. This is your curve. You don't know what the curve is. You don't know what the curve is. Suppose I add some constant value, constant c. Add, it's a positive number c. So what will happen? It will shift c units upwards, right? Suppose similarly, if I subtract this, it will shift c unit downwards. Now instead of adding outside, I can add the c to the inside the argument, right? Instead of x, I can have x plus c. So what you're doing, you're shifting now left and right, right? What happened is here, whatever value this x was giving, right, at 0, now it's giving at minus c. Instead of 0, it's giving at minus c. That's all. You're just shifting the graph to the left. So similarly, if you have, say, f of x, sorry, x minus c, it will shift the graph. Which is this? You can have this graph shifted 1 unit to the right. This will be the next graph, what you get. So x, say, minus 1 also. Now you can see when x is 1, it's 0. When x is 2, it's this point, right? X is 2, it's this point. The previous point, you would have got the same value when x was 1. So it's shifting 1 unit to the right. Okay. So this is a general observation, right, for any graph. So why are graphs important? See, these are the curves. You already, before even drawing the curve, you said it's a parabola because you've seen this before. Okay. That's why you know it's a parabola. But for graphs like integer part, fractional part, what you have seen, you didn't know the graph. At least majority of you didn't know what the graph looked like. But taking real points and plotting is very important, right? So that's why we do this graph in 10 standard. Okay. So suppose this is x squared. Will anything change if I have something like this? F of x is equal to, say, x squared plus 5x plus 20. What will the graph look like? What will the graph look like? Will it be a parabola? Will it be something else? Okay, for this you're saying it's a parabola, right? Right? Even before drawing, everybody said it's a parabola. Correct. Is this also a parabola? What do you think?
Yeah.
Yeah, it's a parabola. Okay. So when do we get a parabola? That's my next question.
When the equation is quadratic,
When the equation is quadratic, do we get always a parabola? Any quadratic equation given. So suppose I have minus x square plus 2x plus 2, even this is a parabola. Or
Yeah.
if I have say minus 100 x square plus 200x plus 10 power 10, even this is a parabola. My question is to analyze which of these are parabola. Are all of them parabola? What is the condition to be a parabola? That's all. So that's why all of them are parabola. So you're saying if this is x square, that's enough. If this is x square, that means it's a parabola. Is this what you're saying? Yes?
Yeah.
Okay. Then what about this? So suppose I have say y square is equal to 4x. What about this? Now I don't have a quadratic in x, right? I have quadratic in y. Is this also a parabola? Is this also a parabola? No. This is some other curve. Just think for a moment. What will happen? What will happen instead of x square? Instead of x square, right? Instead of x square, this is what y equal to x square, correct? Y equal to x square. Instead of having y equal to x square, I have say x equal to y square. Okay, I just added 4. Let me remove the 4. If you don't want a number, you can imagine this better. Yeah. X equal to y square. What will change? What will change? Can you? Okay, it's better. Let's try to draw this graph itself. No confusion. Draw the graph of x equal to y square.
Will it rotate by 90 degrees?
Just try it. Try drawing the graph and tell me what will it. Did you get the graph? You get the graph.
Yeah.
Okay. How does the graph look like?
Looks like a rotated parabola.
Rotated parabola. Okay. Let us try to
Rotated by 90 degrees.
rotate by 90 degrees. Okay.
It's a parabola, but it's against the y-axis rather than the tangent to the x-axis.
Right?
Yes.
Yeah, I think you can plot the points again. 0, comma 0. When x is 1, y is 1. Fine. But now the problem is, if I take values for y first, when y is minus 1, x is again 1. Can you see the difference? If I simply take for values for x, I agree, usually we do this, right? But here there's a different case. So if I simply take values for x, I'll get only these points. So, right, 1, 2, 3. Because I can't take negative values for x. You would have seen. If I take any negative value, for example, minus 1, on the other side, I have a whole square. Whole square is always greater than equal to 0, right? So I can never take negative values there. So that is one of the problems. So what I do, I take negative values for y and z. It makes sense. So if I take negative values for y, I'm going to get 1. So minus 2, I'm going to get 4. So you see that for negative value, that is minus 2. So somewhere minus 2. So it should actually go to 4. Okay. Let me say this is minus 2. Yeah. Okay, this is minus 2. So it will go somewhere here. So 4. Similarly, on the other side, I'll have this point. Right. So something like that. Right. So this is still a parabola. So any condition for a parabola now? Anything? Because you said it should be a quadratic. So what I did is first we have seen that we have taken a quadratic in x. Now I take a quadratic in y. Still I'm getting a parabola. So any degree 2 equation will be fine. Is it fine? Okay, okay. If it's fine, what about this equation? Now I had 1 degree equation, 1 degree 2 equation in x. The other example was 1 degree 2 equation in y. Now what if I have say x square plus y square equal to 4? So both are degree 2. How will the graph look like? Can you try this now? Again, graph of this. Graph of this. Okay, okay. those who already know what this equation looks like. I think they won't be able to imagine exactly. But now you should take points and see. It's very interesting. Just take some points and try to plot them, and just let me know how it looks like. Take some points, sample values. You tell me what sample values you have to take. We can take, then we can try to draw, and we'll see what we are getting. Right. Is x equal to y? Need not be x equal to y, right? X can be anything. Why should it be equal to y? You can take any sample value. This is an interesting equation because, again, while taking values also we have to be careful. It's not that, see, till now take any value of x, just simply get the value of y and plot it. Now we have to be a bit more smart about it, right? You have to check what values you are putting. Is it so that's why we are talking about domain and all, correct? So does it make sense to take these values? For example, can somebody give me some points on this equation, or what other points should I take so that I can plot? Some examples which will work here. So when, yeah, yes. Yes, you can give any point. Any point is fine.
2, 0.
Or, okay, when x is 2, y is 0. 2, 0. Fine.
Yeah.
2, 0. Okay. Any more you can think of. Let me just plot whatever we are getting. Let me just plot. X is 2. So x is 2 somewhere here. 2, 0. Okay. What next? What next? Any other point? Any other point?
Minus 2, 0.
Minus 2, 0. So when x is minus 2, just saying again we are getting 0. Yes. If you have a doubt, please check here. Okay. So when I take x equal to 2, I'm getting 4. So 4 plus 0, yes, it is equal to 4, right? How are we getting this? Simply take a value for x and find out the value of y. When you put x equal to 2, so you're already getting 4 equal to 4. So obviously y should be 0. Okay. So I got two values, 2, 0 and minus 2, 0. Any other points do you have? Any other points do we have?
0, 2.
0, 2. Okay, 0, 2. 0, 2. Okay. So 0, 2 is somewhere here, correct? Fine. Yes. I think the fourth one is pretty obvious, right? So 0, minus 2. This also work. Fine. Should I plot that? 0, minus 2 somewhere. Okay. Now if we have 4 points, is this enough to get our graph? Is this enough? Yeah, it's enough. Okay, can you tell me what the graph is then? Oh, is it? It's a circle. Okay. Why can't, I have a doubt. Why can't it be something like this? Isn't this valid? Right? Isn't this valid? Can't it be this? Can't it be this? Or if you're not happy with this, let me have something different. So like this, something like this. Did you check for any other points? How do you know? How do you know it's a circle?
Circle
Problem
formulas.
is, that's the problem, right? We first by heart the equation, then come here and think it's a circle. We don't exactly go and plot those and check whether it's a circle or not, right? Why can't we be sure it's a circle? Why should we guess? We plotted 4 points, correct? We took 4 points and it is a random 4 directions and we are saying it's a circle. How do we know it's a circle? Even for the equation, looking at this equation, can you say it's a circle or some justification you have? Or somebody told you that's why you're assuming it's a circle?
We had learned it last year.
Yeah, you learned it last year. So any justification that it should be a circle? Because we are trying to plot it, right? We are trying to plot it. We have got 4 points and we are just assuming it's a circle. Anything else we can do just to solidify that it's a circle? The radius should be 2. I don't know all these things. Where is it coming from? I know the formula where you are getting it, x square plus y square equal to r square. That's why radius is 2. But why are we getting that? I'm simply trying to draw the graph of this one, this simple equation, right? And we are stuck at 4 points and we are saying it's a circle. Can we do something else? Can we get more points at least? Can you think of one more point? Then we'll go ahead from there. Root 2, root 2. Yes,
Yeah.
fine. Root 2, root 2. Makes sense. Right? Any more points? That's it. Well, let me just try to plot it. So this is 1, right? If this is 2, this is 1, this is 2. So root 2 is approximately 1.4, somewhere here. So similarly, this is 1. So 1.4 would be somewhere here. So somewhere here, this would be my point. Yes. One more justification probably I can have, if say this is the point 1 comma 1 and this should be a straight line, right? Something like this. I think I better extend it from behind. So it should make 45 degrees. So I think this would be a better justification. The point should lie on this line, right? I hope you're getting what I've done, right? What I'm saying is here x and y are equal, so it should lie on the line y equal to x. Okay, so I know it passes through this point, so it should pass through this point also. Simple straight line, right? Yes. What next? What next? Okay, somebody saying root 4 and 0, but root 4 is 2, right? We have already considered those points. That's it. We can find only 5 points, that means, is it?
No,
1
we can
and
find
root,
8.
yes. Root 16 and 0. Root 16 won't work. Can you check? Just put root 16 here. So this is equal to 16 directly, you know. So root 16 square is 16. So 16 is not equal to 4, certainly. So it fails. So see.
We can get 3 more points.
Yeah, what are the points?
Root 2 and minus root 2.
Yes, root 2 and minus root 2 works.
Then minus root 2, root 2.
Minus root 2, root 2 and
Minus root 2, minus root 2.
okay, minus root 2 minus. So minus root 2 minus root 2, again the same justification. It's x equal to y, so it should lie on this line, I think, right? Similarly, you can continue, but I'll randomly plot for now. I think somewhere here it will. So we got 8 points. We got 8 points. Can't we have some more points?
Root 4 comma 0.
Root 4 comma 0 is same as 2 comma 0, right? Right? So we have got that covered. Root 3 comma 1, yes, that is another point, yes. Root 3 comma 1, you can see that, square them. So root 3 comma 1, where is root 3? Root 3 is here, somewhere here, root 3 and comma 1. So 1 is somewhere here. So it's somewhere here like this. So you can see, if you got this, probably you can guess. All these will be your points, right? All these will be your points on the circle. Correct. So can you see that we're not randomly guessing now? We have a lot more points, right? So this is root 3. So we will have some more points here, I guess. Correct. So we'll get these ones. Now, can you see that by getting more points, I'm not simply guessing because the equation was given. Now it looks like a circle, isn't it? Still, you can say these can be straight lines. These can be straight lines. Why should it be a circle? You can ask that question. But then I will tell you, take more points. You're all taking standard numbers. Nobody said it should be a whole number here, right? And we told you it should be a whole number. There are a lot of points. But between 0 and 1 only, there are infinitely many points you can choose for x. Choose any point you like. Choose half. Half square plus y square is equal to 4. Correct. So half square is 1 by 4. That means y square is equal to 4 minus 1 by 4. Or if you want to simplify it, it's 15 by 4. I know it's not a standard number, but still this is point, right? So y is what? Plus or minus root 15 by 2. You are getting two solutions. That is for half comma root 15 by 2. This is one of the points. Half comma minus 15 root 15 by 2. Obviously, you can interchange them and still get more points. So you can see you can get more points. So getting more points will fix that this is a circle, right? Something like this. Okay, it's not exactly. Let me move somewhere. Yeah. Right. So it is not that equation is given, then we directly write it a circle, and next time I ask you to draw the graph, because we know a circle, we draw a circle. So yeah, you will learn these points, that this is the radius. So later on, you can directly write 2 radius. Center is 0, 0. Later on, yes, obviously you can use it. Not every time you're going to plot the points, but you should know at least when the equation is given how to plot points. Right? That's the whole goal. See, looking at this equation, if you had tried x equal to 3, right? When you tried x equal to 3, this is 9, and y is a positive number. This can never be equal to 4, right? So there are a lot of things you learn. That's why you can see in the graph, after 2, you're not getting any other point. You can see this is all empty, right? Similarly, less than -2. Again, if you go less than -2, this will be greater than 4. Again, you have no point this side. So all of your points lie between -2 and 2. The reason is, on the other side, you have 4, correct? So, and both are whole squares. So both are positive. So once you cross 4, you can never be, other number can never be negative. So you're not going to get any other solution outside -2 and 2. Is it clear at least, right? What to do? Right? So one last graph we'll see. Now you can draw by plotting points, right? Because we have discussed this many times in the class. So y equal to 1 by x. You can draw the graph of this. We have discussed this many times about what will happen, etc. And we have discussed the domain, range, everything, and this similar problems to this equation. So now we'll draw the graph. We'll see whatever we analyzed, whether it was right. How does it look on the graph? So we'll try that. Yes, Karthik, what is your doubt? What about the points inside the circle? What happened about those points? Can you speak up so it is easier? I don't want to read the chat and do that.
Right.
So,
The points inside the circle won't be the solution, right?
no, it won't. See, just choose a point. 1, 1, is it inside? It is inside, correct? So if you put in the equation 1, 1, what are you getting? You're going to get a number less than 4. So usually, actually, what happens is, if the sum is less than 4, all the points are inside the circle. Right? That is also a point that you learn later. It's not that important for now, at least. So any number you get whose sum is greater than 4, it will be outside the circle. So see, just imagine we're saying it's equal to 4, correct? So equal to 4, that's why we're getting this curve. Anything less or more shouldn't be there on that point, right? Otherwise, we are drawing the wrong graph. So what happens if it's less? All the points inside the circle are certainly less than 4, right? And all the points outside the circle are greater than 4, right? So that's why I said it's very, very nice to simply randomly take an equation, right, and try to plot it. See, if you are actually genuinely drawing it, at the first time, what will happen is when you got these 4 points, you would have thought, why can't it be a rhombus? Makes sense, right? To be a rhombus, you got 4 points. You can join it any way you like. Then you should go for more points. Why are you not getting points here? Why are you not getting points here? Similarly, why are you not getting points here? All these things you have to analyze. Anyways, yes. Let's go to the next. Okay. It's not clear, sir. Little far away. It's not. Still, I can't see. It's looking. Yeah, somewhat similar. It's somewhat there. Okay. Yes, Stuti. What about you? Yes, somewhat there. Yes, correct. It would be an L shape. Okay. Not L shape. I think probably the axis is only L shape. Correct. So L shape is, I think, the axis. So something different. Let's see. Let's plot. It's fine. And I'm not expecting everybody to get the graph right. Our whole point is to try that graph so that it's better So next time anybody asks you to plot a graph, don't say, I don't know what the shape is, right? You get the shape from plotting the graph. It's not the other way. Somebody tells you the shape, you don't draw the graph, right? So usually what, it's an equation. What we do is simply plot it. Or then we see, okay, it's a standard shape. Okay. Then we name it. That's the usual process. Correct? Yes. So when we took some points, I think standard points would be, I think x equal to 1, everybody would have taken, right? So something here. When you take x equal to 2, this is half. Correct? When at x equal to 2. But if you take x equal to half, which is somewhere here, you're going to get 2 because this is a reciprocal. That's it, right? So you're going to get 2, something here. Now you can I think see where we are going with this. Correct? So when you take 3, it's 1 by 3. It's not exactly half of this, but it's still certainly less than that. Then it will get 1 by 4, then 1 by 5. Certainly it's going less, but it will never touch your x-axis. This is x-axis because it can be 0. We have seen only at infinity. Correct. So we're not gonna touch 0. So I think I can extend the graph at least for a year. It will go something like this. Very close to x-axis as we increase the numbers, but not exactly touching x-axis. Similarly, now we have discussed what happens when x is very close to 0. Right? I told you there's no exact value at 0. This is the reason. Again, from the graph you can see. When you come closer to 0, now it will be 1 by 3 will be what? Okay, it's becoming a straight line if I hold it too long. So it will be 1 by 3 will be say something here, here, here. It will be again a tangent to y-axis. Again, not touching y-axis. You can extend this line, I think, if you want to see. Something like this. And here also, you can extend this line. Let me just draw it again. Somewhere here. So it is, so on the negative side, I think once you have got this, you can simply apply values, negative values. It will be something like this. Again, not touching x-axis. So I don't want to draw something wrong. Yeah, somewhat here. I think this would be a better way. Very. This should be straighter. I think. Yeah, this would make much more sense. So let me just. This looks smooth, so let me just draw this. Let me just delete this. So drawing, I can simply draw one more curve here. Yeah. Somewhat like this. The points are now not according to scale, but so can you see at 0? See, when I come close to 0, one side I'm seeing it's going up, right? Shooting up at positive infinity, right? Because it's not touching also infinity, but it's going up to the. On the other side, when you come from this side, you see it's going negative and minus infinity, what we are discussed, right? So exactly at 0, what happens, we don't know. So this point, it's not 0, sorry. Let me just have remove this point. It's not actually 0. At 0, there's no particular value. At 0, there's no particular value, right? So this is a curve. Okay. So I think by now you people are used to, these are some standard curves we have taken. This is again actually a rectangular hyperbola. Anyways, the name is not important, right? So we should know how to take values and just draw the curve. What will happen if I multiply by 2? All these things I'm interested in. So here also, at the end, I had asked you what would happen if I multiply this with 2x square, right? 2x square, what would happen? So again, you could see that it would come closer to y-axis. Why this happens? It will increase faster, right? So it's already multiplied by 2. So before, when x square was 1, right, it will remain 1. But now we are multiplying by 2. So at 2, 1, it is going faster, right? So that is the reason. So if I, instead of 2, if I have a smaller number between 0, say 0.2, now it will expand, correct? This 0.2 means similar as dividing. Instead of having something like x square by 2, this is what? A number between 0 and 1, correct? 1 by 2, which is 0.5, right? So you can say that here we have discussed these 4 points, correct? So again, now we can think of what will happen. Say, let me write it in a different color. F of kx, and say again, f of kx we can take different cases itself. When k is greater than 1, what will happen? And k is between 0 and 1. We can think of negative again, but when you take negative, the curve itself will change. Now we are thinking about compression and expansion only. So what will happen to the curve, right? So when this is greater, what will happen? It will come closer to x-axis. So suppose this was a curve. This was, say, y equal to x squared. Let me just draw it again. Yeah. Right. This was y equal to x squared. Now 2x squared would be something like this. It will become very closer to y-axis. Something here, something like this, right? So instead, if you have something divided, by divided I mean a number greater than 1, or if you have, say, k between 0 and 1. For example, if you take f of x equal to, say, 0.2x squared. Now the curve would be something like this, right? So it will be little away from a y-axis, or we can say expansion in some words. This is true for all the curves. That's why I wrote a generic statement here, right? In general, any f of x you take, this is what is going to happen. You can imagine why it happens also, even for straight lines. So as I explained that time, so here you're multiplying by 2. Earlier it was 1. So earlier what value it was giving at 1, now for the same point, it's giving actually 2. Earlier, whatever this value was, now it was, say, 10. So now at the same point, we're multiplying by 2, so it's 20 now. Correct. Now, other way, you can think about this graph, what is happening. So earlier at this point it was 1. Now at that point it is actually 0.2. The value of y is 0.2. Here it was 10. Here it was 10. Now we are multiplying 10 by 0.2. So it is only 2. So that therefore it's slow. So it's slowly increasing means it's expanded, right? So that's the way to look at it. So we'll quickly try to solve all the problems, right? I think we can take a break for 5 minutes. We'll take a break for 5 minutes. 5:30. 5:30 we'll start with the problems. We'll end all the problems. If you have time, we'll go back and complete that small part. Today would be the last class in functions and graphs. Therefore, I will complete everything here. Yeah? Okay. Any specific doubts also what you have regarding to this chapter, we can ask. Yeah, those have asked some networks, but we can't brief entire thing. It is 1 hour. So what I've done is discuss graphs, the entire graphs. So that's all I can tell you right now. Okay. So let's start. So a simple problem at the start. I think write an equation to represent the function of the following.
Y equal to 2x.
Yes.
Y equal to 2x.
Okay, this is not B, I think. Okay. Y equal to 2. Yeah, we can just see, right, what happens to y. See, it's -2 here, it's -4. It is -1 here, this is -2. So 0, I think we can't analyze much here. But 1, everything is multiplied by 2, right? So directly, I think y equal to 2x, correct? Or nothing much here, okay.
Yes, sir.
Next. Similarly here, okay. So now for -2, we are going to -1. I think if you want to think about the product side, it's -12. But if I see the next number, again, it's not multiplied. So probably not multiplication. I think somewhat like a GMAT problem this is, right? Now, because the options are given, it's much more easier. Now, one thing I think from 0 to 3, if it's going, it's certainly not multiplication or division. So there must be addition at least. So +3 would be one of these easier hints. So just cross check with others. I think +3 works, right? So easily your answer is x plus 3. So should be y plus 3. Okay. Nobody's waiting still. Okay. Which of the following relations is not a function? A, B, C, D. This is not a function. B. Okay. Now I think here in A we don't have any problem, right? All is mapped. Here B, I think we certainly have a problem. One value, 1 is mapped to 2 numbers. It's certainly not possible. Correct? So this is wrong. Other, just cross check. I think this, even C is fine. Even D is fine. There's one element, 1 remaining, 12 remaining, but that's okay. That's okay. That's not a condition for a function. Okay. It is certainly if that 1 and 12 was in our domain, then we would have an issue. But it's in the codomain, we don't have an issue. So your answer is B. Okay. So f is a function from A to the set of whole numbers as defined as follows. Again, there's a function given and something is happening to it. What is the domain of f? What is the domain? The set of integers. Okay, some people are saying A. Okay. What do you think is the domain is?
Set of integers.
Set of integers. Okay. Any other answer we have? So one answer is set of integers. Okay, this is repeating. Set of integers. Oh, any other answer we have? Any clash? No. Okay. What is ours? What is ours? The domain of f, right? Domain of. Let me write this. F of a. A to b. What is the domain? What is the domain? A or b? A or B? What is domain?
A is the domain.
A is the domain, correct. So what is told here? Again, this is set A. F is a function from set A to whole numbers. Isn't A the domain? Isn't A the domain? So what is A? Isn't set A this C? Isn't set A C? So why is the confusion? Some people are saying A, some people are saying D. See, range is D, no doubt. A is nothing but your codomain. We have discussed this, right? We have discussed what these terms are. See, in A and B, this is your domain. Okay, this is your domain. This is your codomain. Range is what? When I put the values A, all these elements of A, what output I get is the range. So in this case, the entire Y would be a range, which is specific 0, 1, 4, and 9, not set of whole numbers, but these 4 would be a range. So you can see in option D, there is a range. So you can't forget this definition. It's very important, right? Domain and range. Okay. Which one of the following graphs does not illustrate a function? Now we have seen a lot of graphs. Can you tell me which of the graphs is not a function? Right? Okay. All of you are answering C. C is correct. Any justification, anyone? Why C?
The graph says that one value of x gives all the values of y.
Okay, one value of x, for example, whatever this is, x equal to a. For x equal to a, right, we are getting all different values of y. So, for example, I take y equal to 1, I'm going to get x equal to a. So, y equal to 2 is still x equal to a. So, in other words, when I talk about this as the input, for x equal to a, I'm getting different outputs. Correct? So, therefore, this is not a function. So, we have seen a lot of graphs before, right? So, we'll think about it later. Okay. Again, when some more problems come, probably we can discuss. Yes, again. Okay. Which of the following is not a function now? Okay. The different answers again. Okay. B, C. Others are looking better, I think. Easier graphs. So everybody. Okay. So many of you are answering C. Any justification by C? Any justification for C? Okay. What is the easiest way? See, I draw a random graph. Okay. I'll just. Is this a function? Doesn't make any sense. I randomly drawn something. So is this a function? How will it check? These are standard graphs what is given, but what I have drawn is totally random. So how will you check whether this is a function or not? Any easier method anyone has? That looking at the graph, I directly can tell this is a function. This is not a function.
Drawing a line towards from the input and seeing whether it produces two or more outputs, and you can find the
Yes, that's correct. So what he's saying is, you just draw a vertical line, right? So it should be straight, obviously. So some straight line. Okay, I'll just change the color. It will be easier to draw. So something like this. Now, if it cuts at 2 points, not a function,
Yes, sir.
right? You can imagine why. For one input, this is x equal to something, whatever, say 2. For one input, we are getting two different outputs, not a function. That's why I asked in the last problem also, why is it not a function? See, some people answered C, but you take any vertical line. Okay, it should be straight, obviously. If you just draw a slant line, you'll get more points probably. But you can see it is cutting at only 1 point. So at 1 point, I'm getting only one output. It's a proper function. C is not the answer. Some people answered D. Again, take any line, right? So you're going to get only one value. So why we are not randomly drawing a line and just guessing? See, when I draw a line, that means what? For one particular x value, in this case, whatever this value is, I'm trying to check how many outputs I have. That's why I'm drawing the line. Now, if it cuts at 2 points, that says what? That says for that particular input, I'm getting two outputs, which is not a function. So we are drawing this graph. It's fine. I'm not saying these graphs are wrong, but is it a function? No. Is it clear? So if you remember what this graph is, not exactly, but it was similar to y square equal to x. Correct? So what will happen is when you take y equal to, you write in terms of x, you'll get root x. But if you take plus or minus root x, right, that's when you have a problem. So for one input, you're getting two outputs, right? When you take 2, you're getting plus or minus root 2. So that's why the problem comes. But if you had taken only one of those values, then it will still remain a function. Obviously, this won't be the graph. Only half part of the graph will remain, something like this. Okay, fine. You get the idea. Okay. Next, which is not a function. I think already I've discussed this. So, what's your answer? Clearly C. C is not a function.
Yes,
Because, yeah, you take any value, you take 3, you're getting plus or minus root 3. So x equal to 3 I take, I'm getting two outputs, not a function. So C is not a function. Yes. Okay, this is something different. Okay. Any answers here for this problem?
Option D.
Option D. Okay. What is this? What is this GOF? GOF of x.
G of x. G of f(x). Something.
Okay. This is actually even written as G of f of x. Right? It's called a composite function. Right? So it is G of f of x. So if I write f o g, so this is nothing but f. Sorry. So if I write this, this is nothing but f of g of x. You may think, what is this g of f of x? You know what is g of 2 and all, right? What you do? In place of x, you put 2. Correct. That's all you do. Suppose I give you g of x is x square and ask you what is g of 2. You say g of 2 is 4. Correct. Now what are they asking you? Instead of x or something like that, put f of x. That's all. That's all they ask. So what will you do? G of x is cube root of x minus 1. Now g of f of x. What is g of f of x? G of f of x is nothing but g of 4 by x. So in place of x, I have to put 4 by x. That's all. Nothing new. So in place of x, I'm going to put 4 by x. So it is 4 by x minus 1. Is it clear? Is it clear? Now, can anyone tell me what is f of g of x equal to? F of g of x. What is f of g of x equal to?
A.
A. Yes, that's correct. So this is not the answer though. Okay, I'll just write it separately. So you're talking about f of cube root of x minus 1. So in place of x, I have to put this. It was 4 by x. Now in place of x, it is cube root of x minus 1. So it's done. This is fine. Is the method clear at least? So it's a function. We'll learn more about complete function in the higher classes. But now, for now, it's simple, right? We used to plug in numbers instead of numbers. Now they're just giving you a function there inside. So if they say this is g of x, what is g of x square? In for this equation, this is nothing but g of, in place of x I have x square. So x in place of x, it's x square. So it is something like this. So I'm going to get x power 4. Is it clear? Are you able to follow? Everyone, any doubts you can ask? Right.
So the question is asking g of x. So for cube root of 4 by x.
So yes, g of f of x, right? This is the answer. Option D is your correct answer.
Yes.
Yeah. No, I just for practice I had given this. That's all. Next, which of the following is not a function? Now I think after I told you method is easy. Draw a straight line anywhere here, it's a function. Draw a straight line here, it's a function. Draw a straight line here, again it's a function actually. But here you can see if I draw a straight line, it's cutting 2 points, right? It's cutting 2 points. So giving me, say at minus x equal to minus 2, 2 outputs I have. So therefore not a function. So A is not a function. The rest all options are a function. Okay. Yes, f of x is given, g of x is given. Please compute the value.
Option D, I guess.
Yeah. Let others compute. Those are not done. So quickly you can compute. Okay. So majority of you have got the answer. So let me see. G of 2 is what? So one by one we will simply calculate. And G of 2 is 2 square, which is 4, minus 10 plus 6. It's 0, I think. Yeah, great. G of 3 is again 9 minus 15 plus 6. Again, that's 0. G of 0, it's 0 plus 0 plus 6. So numerator is 6. Denominator, now it's, you have to check for this function. It's f of x, right? F of 0 is 0. F of 1 is 1. F of minus 2 is 4. So it's 6 by 5. Simple calculations. Fine. Okay. Now, f of x is given. You have to find, see now instead of f of g of x, they are directly given you what in place of x. Now we have to put 1 by x. Right. What are we going to get? Where are these problems given? I gave you a soft copy, right, in the class. I don't know if you have attended. It was given in the class. Oh yeah, I have not uploaded it anywhere. I don't know if we can upload that. Probably whenever you come next, you can collect it. For now, you can note it down. It will be there in a textbook when you get it. Textbook or workbook, one of them. Yes. f of 1 by x. So in place of x, I'm going to put 1 by x. Okay. So it is 1 by x whole power 4 plus 5 into 1 by x whole square plus 1. Now simply I need to do the simplification. 1 by x power 4 plus 5 by x square plus 1. Now take the LCM, because if the options were something like this, directly we could have written the answer. But these options are all in terms of f of x. Let's see, the LCM here is x power 4. So what will happen? So this is 1. This will be 5x square, because to get x power 4 I have to multiply with x square. To get x power 4 I have to multiply with x power 4. Now can you see the numerator? It is nothing but f of x. Right? So one simplification you have to do. So if you get the numerator again as f of x, so option A is your correct answer.
So you could have stopped like after taking an LCM because out of all the four options, only the first one has the whole extra whole.
Yeah. If you could guess it from here, it's fine. But because there is option B, right? Then this is a fairly straightforward problem. But because of option B, there's sometimes what will happen, one of the x you might get from here or something, and then still it could have been the answer, right? So we can't be very sure, right? So in this case, if we can be very sure, because it's a directly simple division of x power 4. Some other more involved problem, so it's better to simplify at least one step, right? Right? Okay. Find the domain of this. Can you find the domain? Okay. See, we are finding the domain. Numerator, need not check anything. Domain means it should be undefined. So I have to look at the denominator, because whenever there is a denominator, see, for a polynomial, it is always defined. Now, because the polynomial is in the denominator, it can be 0. That's the only concern. If the denominator is 0, we have an issue. Let's just try check. Can this be equal to 0? So I think if you factorize, you're gonna get
2 and 6.
yes. 2 and 6.
X equals, yeah.
Yes, 2 and 6.
So I think if you factorize, this is what you get, right? So the solutions are x equal to 2 and x equal to 6. So for these two values, it's not defined. So the domain will be entire set of real numbers minus these 2 points. Fine. Okay. Somebody put 8 also. I don't know if 8 shouldn't be an issue, because it's a quadratic equation. There can be only 2 roots.
Only 2, sorry.
Yeah. Okay, this is f of x. F of x is ax plus beta. I think it should be f of x is a alpha x plus beta, because they ask you to find the values of alpha and beta. And they have given f is something like this. Then the values of alpha and beta.
Option A.
Okay. See, what does this equation say? This is another way of writing a function we had discussed at the start, right? It says that f of 1 is what? F of 1 is equal to 1. This is what it says. And it says that f of 2, when I put input 2, I'm going to get the output 3. Right? So when I put f of 3, I'm going to get 5. This is what it says. Correct. So what you have to do, you simply put on the values. So f of 1 says it's equal to 1. On the other side, when I put 1, I'm going to get alpha plus beta. Fine. F of 2 is equal to 3. It says when I put x equal to 2, so alpha into 2, which is 2 alpha plus beta. So you have two equations, two unknowns, easily you can solve, get your answer. So what you have to do, probably multiply the first equation with 2. So I'm going to get 2 alpha plus 2 beta is equal to 2. Just subtract these two equations. So you can subtract either way. So 3 minus 2 is 1. Beta minus 2 beta is minus beta. So beta is nothing but minus 1. What is alpha? If beta is minus 1, I think you can substitute in this equation. 1 is equal to alpha plus minus 1. Take minus 1 to the other side. So it will be plus 1. So alpha is equal to 2. So alpha is 2, beta is minus 1. Any confusion here? No, it's clear. See, this is another way of writing input and output. I've told you functions. We had a diagram also 1 to 2, right? This is one way of mapping. This is one way of writing. This is input. This is output. So either way you can write. Okay. Next. Okay. This is a bit of problem unless we know. Let's see. Everybody know any properties of plan X? No, right? Okay. So I'll directly simply solve. So let's see if we're getting somewhere. So f of 2008. This is nothing but 7 power 1 plus ln 2008. Denominator is what? 2008. So ln 7. Okay, fine. Numerator, if I want, I can write it as 7 into 7 power ln 2008. So actually, denominator again, you can interchange this and write it as 7 power ln 2008. It's again using property of logarithms, right? So these two will get cancelled. You'll get your answer. If you've not learned logarithms, do not worry about it, right? Okay, those I've learned, so I've simply showed the solution. Okay. Yes. F of 0, f of 1, f of 2 are in. GP. Okay. Yeah, I think it's a simple problem. See what is f of 0. F of 0 is 2 power 0, 1. Correct. F of 1. F of 1 is 2 power 1. F of 2 is 2 power 2, which is 4. F of 3, if you want, you can check. 2 power 3, 8. So clearly it's not AP. So this is into 2. So again, into 2. It's multiplication. So clearly it's G. If there was none of these, probably I had to check for some more numbers just to confirm. Anyways, this equation was very clear. It's 2 power x, right? What is 2 power x? An exponential function. Exponential function means what? Every time I'm multiplying with the same number, that's all, right? So it is 2 square. The next time to get 2 cube, I'm multiplying by 2. So somewhat like that. So that's how I'm going to get G. Okay. Again, f of x is given. You have to find f of x plus 3 divided. I think this should be small x again, not capital X. There's nothing capital X here. So, sorry, capital S. So it should be smaller. What is AGP? AGP is okay for the previous problem. AGP is arithmetico-geometric series. I don't think you have it in your syllabus right now. So it is a combination of arithmetic and geometric series, right? So it is something like this. So if I have to write, it's 1, then 2x, then 3x square, 4x cubed, something like this. There is a formula for these things. So you can see the numbers, right? Numbers are in AP, correct? And this x is in GP. I'm just writing x, otherwise it will be a bit of confusion. So you can simply write, say, 1 plus 2 into, say, 3 plus 3 into 3 square plus 4 into 4 cube plus 5. This is again AGP, arithmetic geometry. There is a formula for it. It's quite lengthy, not like AP and GP. But they don't ask arithmetic geometry series, but they ask arithmetic geometry series for up to infinity, because that is a smaller formula. But I don't think it's required for intense standard, right? I think it's for only 11th. So you need not worry about it. Some of the problems are taken probably from the 11th syllabus. Okay. So did we get the answer here? F of x plus 3, what is this? So simply I'll write, in place of x, I'll write x plus 3, that's all. Okay. F of x minus 1, in place of x, I'll write x minus 1. That's all we do, right? F of 2 is asked, in place of x, I'm putting 2. Instead of that, I'm putting x minus 1. So what is this? I'll just simplify this. This is 2 power x into 2 power 3. I think a power m into a power n is a power m plus n. This you would have learned. So this is 2 power x into 2 power minus 1. Okay. So 2 power x gets cancelled. 2 power minus 1 is nothing but 1 by 2 power 1. So it will be 2 power 4. Right. Now what is 2 power 4? So 2 power 4 is nothing but 2 power 4 is nothing but 2 power x, right, in this equation. So I just have to equate this. So if x is equal to 4, it will be f of 4. So f of 4 is nothing but 2 power 4. Okay. Fine. Again, it's logarithms. So I'll directly solve the problem for those who don't know logarithm, do not worry. Actually, the syllabus should have been, first you have to complete logarithms, then come to functions, right? So it was not done that way. So that's why these problems are there. Okay. Need not worry, we can take up in logarithms. So yes, Saura.
Is it A or the alpha of the bracket?
Is it? That's all I can hear.
Is it A or alpha?
A or
Alpha.
A. It's everywhere A. It's A. If you take alpha, everywhere it's alpha. That's all. Right. So everywhere it's A. Nowhere alpha. Okay. Fine. Now what is asked? It's asked that I take half of f of 8a by 4 plus a square. In place of a, because the variable is a, right, not x. In place of a, I have 8a divided with 4 plus a square. Let me try to apply that in the formula given. So half of, this half is from this half, okay? It's outside. So log of 2 plus, in place of a, it is 8a by 4 plus a square divided by 2 minus 8a by 4 plus a square. Okay. Now I'm going to take the LCM. Take the LCM. Half of log. So this is 2 into 4 plus a square plus 8a. I'm taking LCM. I didn't write the denominator yet. I'll tell you why. 4 plus a square minus 8. Now you can see that denominator is both is 4 plus a square, 4 plus a square. It will get cancelled. That's why I didn't write the denominator. Okay. So both will get cancelled. If you want, you can write one more step and then you can simplify. Now this is half log of, what is this terms? So let me see. So 2 is common, I think. So let me take 2 outside. So a square plus 4a plus I think 4. Denominator is, again, if I take 2 common, so it's a square minus 4a plus 4. Now, if you have a doubt how directly I wrote this equation, right? So, see, 2 was here outside, so I took 2 common from this side also, right? So, this became 4a, that's all. Fine. So, a square plus 4 was anyways there. So, this side took 2 outside and got 4a. Why I did that? Because, see, instead of multiplying with a square, I can simply cancel that off. That's why I did. Because all were even numbers, so I thought 2 is common, let's just cancel it out, right? Instead of writing. So what is this equal to? So this is equal to half of log. Can you see that numerator is nothing but a plus 2 whole square Denominator is a minus 2 whole square. Fine. So this is nothing but half of log a plus 2 by a minus 2 whole square. Now, if you know the property of logarithms, so this 2 can be got down like this because there is a power theorem there, right? So if it is log of n power n, we get the n times log m, right? Once you learn log, you'll understand. So this 2 will cancel. So this is what remains. Now there's a confusion here. Can you see that? What is your answer now? I'm getting my final answer as log of a plus 2 divided by a minus 2. What do you think the answer is? What do you think the answer is? Nobody. We've got a final answer. We just have to choose the option. What do you think? Oh, A and D is right. Sorry, so A and D should not be same. So I think I'll change this D option to f of minus a. So what do you think the answer is? A, B, C, or D? D. Okay. D. Okay. The actual answer should be A, right? You're going to get f of A itself. Any issues here? No. Do you agree with my answer?
Sir, how is a minus 2 equal to 2 minus a?
Oh, a minus 2 is not equal to 2 minus a, correct. But
Yeah.
let me see here. If this, I completed a square a minus 2 whole square, correct? Correct.
Yes.
So if I written this as 2 minus a whole square, do you have any issue?
Oh, no, sir.
No, right?
No.
So if that means my final answer would have been 2 minus a. If I had taken 2 minus a whole square here, this would have been 2 minus a. So here also I would have got 2 minus a, correct? Do you agree? Now one more doubt I have. So is these two terms same? Is these two terms same? 2 minus a and a minus 2. Is it same?
No.
No, they're not same. Then how are we getting both? See, by the logic, we're getting both as answers, right? I've shown you. First time I've got this. The second time I told you, instead of taking this whole square, I'm going to take this whole square, and I've got this. So what should I change? Am I doing something wrong?
How is a minus 2 whole square equal to 2 minus a whole square?
How is okay. So x minus 1 whole square is what? Okay, we can take the same example. Why should we? Can you tell me what is 2 minus a whole square? What is 2 minus a whole square, Karthik?
4 minus 4a plus
Hmm.
a squared.
Is it same as this?
Oh, yeah.
So it doesn't matter, right? Inside the whole square, if I multiply by a minus n, how does it matter? Correct. That's why they are same. But you see the issue. Once I remove this whole square, the sign is important actually. I'm removing the whole square. How? Using the logarithm property. Now it is important. So obviously here it was not important, but if I were to get it down, it is important. But if I take this first case, it is wrong. Why? I'll tell you. Sorry. Yeah. If I take the first case was this, right? This is the first case I got. Correct. So this is wrong. Because a is given to be a number between 0 and 2. That condition was not there, probably we have to analyze it differently. Because a is a number between 0 and 2, what will happen is this will be negative, and log of negative is not defined. I told you, right? In the domain, we can't have negative numbers. Correct. But you can see that in this case, we'll have always positive number. So this is the function we want. So we can never write this as a minus 2 whole square. Or if you want to write it like that, you can't remove the square. So you have to write this as 2 minus a whole square itself. So that way, this would be 2 minus a. And here your answer would be 2 minus a. Therefore, your answer would be a. Are you able to follow? What I'm saying is, see, when I'm taking the square root also, say x minus 2 whole square. If I tell you x is less than minus 4, correct? You always want the positive root. So your answer will be 2 minus x. It won't be x minus 2. Is it easy to follow now? This is wrong. If this condition is given, it is 2 minus x. This answer is 2 minus x, not x minus 2. Because 2 minus x is the case where we'll get a positive number. Usually we put mod sign, right? Usually we put a mod sign when nothing is specified. We just want the positive root, right? Or the positive number. But if something is specified, I have to take into consideration. For this case, it was less than minus 4. So I had to take, there are two roots possible, right? As I discussed that time. So it can be either x minus 2 or it can be 2 minus x, because I can write the whole square, either x minus 2 or 2 minus x. So I choose the positive number, which will be this in the entire case, which will be this always. For these numbers, it will always be this. So this is a positive. Is it clear now? Any doubts here? You can directly ask. A bit of confusion maybe, but this is very important. So some of the simple answers, right? They will just simply trick it like this, right? Even though you got the answer, final answer probably they will have some positive root which you won't consider and simply mark the wrong answer. So, okay, fine. If no more doubts, we can move on. Okay, domain of this. Okay. Any answer here? How many problems are there left? Okay, there are a lot of problems. All reals. Okay, let me check, Ashutosh, for your answer. All reals. Can I check for x equal to 2? X equal to 2. Can I check that? So when I put 2 here, minus 2, isn't this 0? Isn't this 0? So all real certainly fails. Right? Always. So I took example 2, so obviously this also should fail, right? So only option might be C or D. But now I think that this example is pretty clear. I take any positive number, this will fail. So answer is C. Right? But that is using options. But without using options also, so options are not given. I'll simply take this equation and check. Okay. The only way this can be undefined is if this is negative, or denominator is 0. Two cases. Okay. First question. Can this be x square plus x plus 1? Can this be equal to 0?
It can be, but
it can
not for real numbers.
So we are interested only in real numbers. So I think the answer would be no. Correct. We are interested in real numbers. So no. How did you check that?
Using the delta thing.
Okay, using delta thing. Okay, whatever the delta thing is, you're saying it's negative. That's what you're saying.
Yeah.
Okay, you're saying the delta thing is negative, so something magical happens and real numbers can.
We'll get root delta will be root of negative number.
Okay, root of a negative. Delta being negative means something root of a negative number I'll get. Okay. Okay, if root of a negative number I get, I know it's something not defined in a real domain. Yeah. It's not defined in a real domain. In other words, you're saying it has imaginary roots. So therefore no real root. So if no roots, that means it will not be equal to 0. Roots means equal to 0. So therefore no need to worry about this equation at all. So we are fine here. Okay. Now the remaining part. Mod x minus x, this should be always greater than 0. Usually greater than equal to 0. but because it is in the denominator, now it should be greater than 0. Okay. The problem with mod x is, sorry, mod x is equal to x. We know the definition when x is greater than 0. So if I take any positive number, it is x. So this will be equal to 0. It fails. Directly fails. Any positive number. But if I take a negative number, the definition is it's minus x. So it is root of minus x minus x. Now you may say that it is minus 2x. It's a negative. It's not a negative number. It is root of minus 2x where x is negative. I'm taking the case x to be negative. Now if x is negative and there's minus 2 outside, it's always a positive number. You take a specific example if you like. For example, x is minus 10. So this is root of 10 because mod of minus 10 is 10. Minus of minus 10. So you see that you're going to get root a positive number. Any negative number you take, you're going to get a positive number. So your answer is C. So without options also easily you can solve. It's not that because options are there, we got the answer. Okay. Yes. Is it clear now? Options are, we are getting from this definition, all numbers below 0 is your answer. So your domain would be minus infinity to 0. Okay. Domain. Oh, this is a bit tricky. We'll come back to this problem because we are short of time. I don't know what other problems are. Okay, okay. I'll just see the problems. Then we'll pick the problems and we'll try to complete.
This is the last one, I suppose.
Yeah, I think this is pretty easy, right? So this is what it should be. You write it on the right hand top itself, right? Yeah, 5p3. Yeah, it's fine. Yeah, what is this? We need the range of this. Any idea? Range. Okay, seems a bit. I think the option is given with domain. So some lot of errors. Okay, we can correct this. Anyways, we will try to find what is asked itself. We want the range of this. First, can you tell me what is the domain of this? What is the domain? You know what is P, right?
No, sir.
Okay. So what is the domain of this?
We don't know what P is.
Yes?
We don't know what P is.
You don't know what P is? Oh, permutations? No. You have not seen 4p3? What 4p3 etc. is? No? Okay. Let's skip this problem.
Sir.
Because we don't have time to explain what this is. So it comes under permutations. Okay, this is a proper definition for it. For now, we are not required. Okay, so okay, this is a simple one, so we can go with this. The range of this. Range of mod of x minus 2. What is the range? Anyone? I think because we have discussed this, so you should know the answer. Positive reals. So in the option
D.
P or D, which is positive reals?
Option D.
Okay, it's not only positive reals, it's including 0. So any mod function x minus 10, mod x, everything, the range is same. Even plus 100. Because this, the least value is 0. It's something like x square. So I'm talking only in terms of range, okay, not in the graph or the real function itself, but in terms of range. X square, x minus 10 whole square, all the range will start from 0. Even though the argument inside has changed, unless you add something outside or subtract something outside, the range would remain the same. Okay, because it's a whole square. Only difference is initially this is 0 when x is 0, but this is 0 when x is 10. That's the only difference. You have shifted the graph to left or right. You have seen the graphs also. So y is the same, right? But the graph is shifting from left to right. That's all. Okay. So the answer is D. Okay. Next. Let's look at this. Okay. The range of the function y equal to root of sine square x minus 1. Yes, Stuti, can you help me out? So let's see. What is the first thing we can do?
Sir, I don't know this one.
No, it's okay. We are just trying. So what do you think of the first? If we are trying to find, okay, forget about the range. So let's see where it is defined first, right? So what can we do about the define like the domain? For domain, what can we do? What do you want me to check?
Sir, I'm not sure about this one.
It's fine. It's fine. If it's wrong, also fine. You will understand how to what.
X should be like an angle, right?
Yeah, x is an angle in radians, so that's fine. So that's why I told you. Whenever we write sin x and tan x, right, we don't think of degrees. That's why whenever we write in terms of pi. When we write in terms of pi, we are taken care of. So it's not degrees, it's radians. So it is continuous. So you need not worry. You can take 1, 2, 3, all are different, well different. Those are not, again, those are not degrees, those are in radians.
The domain will also be in radians only.
Yeah, radians in the sense all real numbers. So pi, see, pi is equivalent to 180 degrees. This is told to you just because otherwise you people are having angles at start, right? 30 degrees, 60 degrees. So triangles, this is what you think of, right? Whenever initially the sign was taught to you using triangle, opposite by adjacent and so on, this trigonometric functions. So you are used to degrees there. Now if I say pi by 3 in a triangle, you are not able to relate, correct? So, but what happens is, but that's why this logic is taught. But whenever we are going to use sine of these angles. It's fine to write sine of 60 degrees, but while plotting, we can't plot 60 degrees. We can plot it in a different way, right? But we can't plot for x-axis. So if x is increasing like this, we can plot in terms of degrees, but not like this variable. So here, if you want to plot, so these 1, these 2, everything are in radians. So pi is somewhere here, right? Sorry, 3 greater than 3, somewhere here. So this is pi. So sine pi is 0, we know that, right? So this is the graph you get. So, sorry, sine pi is 0. So this is the graph you get. This is for radians. Is it fine? We need not worry about radians, degrees, and anything. Just tell me, to find the domain of this function, right? Let me just remove this. To find the domain of this function, what do you want me to check? That's all. I'm trying to find the domain.
Like trial and error method, like is there a particular formula for finding the domain?
No, but can you see the square root here? Don't you think what will be the issue if there is a square root? What is the issue when there is a square root? Like suppose any square root of some equation I give, x square plus 2. What will you check under the square root?
If it's plus or minus?
That's all I want. If it's plus or minus, right? So what should I check for here in this equation? I should check whether this is positive or negative, correct? If it's negative, it's wrong. That's all we want. See, domain, that's all we try to see. Equation might be complicated, but we need not worry about that. Only thing is, if this is negative, if this is all, say, for example, if I had given you sine square plus 10, there's nothing to check, even if it's square root, so on, right? Because it's always a positive number inside. But now there is something minus here, and it is only minus 1. So I need to check. So can you tell me what value sine takes? What value time sine takes?
I don't know, sir.
Sin x, you know what values it takes? No, you have not attended trigonometry.
I missed a few first classes.
Okay. So sin x takes values between minus 1 and 1. Okay. Always it takes values between minus 1 and 1. Fine. If I square it, it will be numbers between 0 and 1. Everybody agrees? Right? If I square it, it will be numbers between 0 and 1. Now the problem is, if the number is between 0 and 1, it's negative, not defined. Everybody agrees? If it's between, but if it is 1, there's no issue. If it is 1, it's fine. If it is 1, this is defined to 0. Any number less than 1, not defined. Is it okay? So the question is, what is the range? I need not find for what values it's 1. The question is, what is the range? So the range is 0. Are you able to follow, everyone? So I just tried to check where this is defined. I figured out when sin x is equal to 1 or minus 1, sin x is 1 or minus 1, it is defined. Okay. But it's going to give me always the same output, which is 1, and 1 minus 1 is always 0. So the range is only one element, which is 0, no other value. Okay, I hope others also could follow. Okay, let me see. Okay, let's try this. The domain of the function y equal to root of x minus 2 plus root of 1 minus x. Anyone who has completed? Not so difficult, right? Yes. So if you look at this first equation, x minus 2, right? X minus 2 means what? X minus 2 should be greater than equal to 0 because the root should be defined. This means x should be greater than equal to 2. Is it fine? Okay. Now, so second root also should be defined, obviously. So 1 minus x should be greater than equal to 0. Or 1 should be less than x. So number should be greater than equal to 2 and less than equal to 1. There is no such number. Therefore, your answer is null set. Is it fine? Okay. Which symbol? Oh, this is a symbol for null set. Okay. So whenever it's a null set, I think you use this empty brackets, or you can use this for null set. Yes, I think if you can complete some more, this you can try at home. Okay, try to draw the graph. I think this we have discussed. Try to draw the graphs of all the three. Okay, if there is any doubt, probably we can discuss. So I'll help you out somewhat. So this you can draw for cases x greater than 0. This is x square. Okay, x is less than 0. This is minus x square. These are the graphs you have to draw. So for positive numbers, one graph you're going to get. For negative numbers, one graph. So similarly here, this is, I think this is V shape, you can figure out. And this is V shape minus 1, it will shift. So that's fine. The first one is a little tricky, that's all. Okay. I think these two problems you can solve. Okay, let me try one of these. Okay, this is the last problem you try. Okay, fine. Find the domain of little more involved problem, right? You can try. Okay. Well, because there's no time, I'll just start off with the first one, right? See, root of minus x, correct? Root of minus x. Now we are saying that minus x should be greater than equal. It's coming weird. Okay. Minus x should be greater than equal to 0. This is the condition. That means what? If I multiply with a negative sign, this is the condition. X is negative. Is it clear? Any inequality and multiply with a negative sign, the inequality changes. So what I have done, I multiply this equation with minus 1. Whenever you multiply, the inequality changes. Okay, fine. For the next part, 2 plus x, because it is in the denominator, 2 plus x should be strictly greater than 0, not equal to, strictly greater. Fine. So that means what? X should be greater than minus 2. So what is our solution? So our solution is, say, minus 2 to 0. I hope you can take some sample values inside and check if you want. Right. So if I take minus 1.3, simply random number I'm choosing. So this is defined. I don't care what the answer is, but this is defined. Even this is defined. I think it's good enough. Good enough. Fine. Second subpart. Numerator, I don't care. It's well defined. It's a polynomial. Denominator is an issue, right? But if you clearly see, there's a mod function. It's always positive. There is plus 6. Again positive. No issues. Therefore, it's the entire set of real numbers. All reals. Okay. The equation looks complicated, but if you just analyze it part by part, right, you can clearly see it's defined for all reals. Okay. So finding range might be difficult for these problems, but domain certainly is not that difficult. Okay. I think that's it for functions and graphs. Right. This is little more. I'll just give you the hint how you can do this. Probably options are given. It's easier. You take a sample value, but just try to complete the square. Right. I'll help you out here. Just take x square minus x minus 2. Complete the square, then analyze what should happen. Probably that will help you solve the problem. Fine. Any doubts you have in general in functions and graphs, you can ask me. Right? In anything particular, you can ask. Otherwise, we can stop here. Or you want me to solve this problem, I can solve this with the last one. Solid. Okay. Everybody is saying solid. Yes, yes. Any other doubts I wanted to?
I had a doubt.
Yes, yes. Ask your doubt first.
Like what is the range of something divided by a quadratic equation? Will it be all reals except 0?
Can you give an example? Then I can think clearly and exactly help you out there. Any example is fine for me.
Like we had got the question workbook, right? X square plus 2x plus 1 divided by x square minus 8x plus 2.
Oh, that particular problem. Which problem? This next one. This one. Okay,
No, the 13th one.
13th one. Okay. Let's see. This one. This is 13th one. Oh, this one. Okay. This is for far more complicated for you. I think you can just start off with something like this. 4 divided by, if it is x square minus 8x minus 2. This you can think of how to. This you can find out. Now this there is a way, but that is more involved. But first you can figure out this how to find out. Can you tell me what the method would be for this here? How to figure out? Anyone? What is the method to find the range for this? Not domain, range. Domain is clear. So if this is y, what is the method to find the range? Don't know. Okay. What you do is complete the squares. So x minus 4 whole square. Right. So plus 16. So I'm subtracting 16. So minus 4. Now you can see the values it takes, because this is certainly a number between 0 to infinity. Is it clear? So what I have done with quadratic equation, I have converted this to 0 to infinity. Now you can see the denominator, how it behaves. Now I can write the denominator as 4 divided by something from minus 4 to infinity. Now I think we have taken up these kind of problems, right? To figure out the range. Remember, you have taken out from minus 1 to 1, what happens? We have taken out from minus 4 to 10, what happens? So you have taken out all these examples. So now you can figure out what the problem is.
Minus 1 to 0.
Yes, yes.
Will it be minus 1 to 0?
Minus 1 to 0. No, there are more parts. See, again, you have to separate the negative 4 to 0. This will give you one range. Plus, you have to figure out 4 to 0 to infinity. So this part itself is giving you entire positive. So your answer is wrong there. Are you able to follow?
Yeah,
Yeah.
I got it now.
Then there is this part which you have to consider again. That's why I said whenever it is divided by, separate it, it's easier to analyze for you guys, right? So I could directly have told the answer, but you have to imagine what would happen, right? That's why from 0 to 1, it's going to 1 to infinity. From 1 to infinity, it's coming back to 0 to 1. So you have done a lot of problems there for 1 by x. That's why I said it's very important. Similarly here, see, this is a quadratic equation, but I converted into something, some numbers. Now we could solve it, right?
Yeah.
Okay. Okay. Is your doubt clear though? Any quadratic equation you can do the same way. This is the method. Now, if you want to find the range of this, that is not so easy. Now, what happens is, even though you convert this and this, they will go in a different pace. So the method for this is actually taking it to y and finding. It's a bit more complicated. You have to write the quadratic equation, then see the roots are imaginary. Why, again, that concept you have to learn in the higher classes. It is there in 11th, that time you understand. Now, need not worry about it. Nobody is going to ask you the range of a quadratic divided by quadratic. Even if they ask you, suppose the worst case they ask you, they will ask you a number, they will ask you this something like this, by plus 4 plus 12. They'll keep these two same so that you can divide them, then solve. Okay. No way they're going to ask you different quadratic equation. Any quadratic equation, by quadratic equation, they ask you, you can divide those. Even linear by quadratic is not so easy to analyze. Again, you have to take, this is the method, but you need not worry about it. For your class, it's not required. Is it okay? Any more doubts?
Yeah, like you had given a question, 1 divided by x square minus 3x plus 10.
Yes, 1 divided by 3x square minus 3x plus 10. Okay, same method. What I
Yeah,
did
the
here.
roots will be imaginary.
Roots are imaginary. Okay, still
Yeah.
it doesn't matter.
So, what would be the answer? Like, would it be all reals except 0?
What are you talking about? Domain or range?
Range.
See, range. See, I'll just write the solution. 1 by, I'll complete the squares. Okay, fine. Those who are done can leave the class. Okay, this is something extra anyways. So x minus 3 by 2 whole square, x minus 3 by 2 whole square, right? So plus what?
Yeah.
I have added, see, if I expand this is x square minus 3x plus 9 by 4. So this is plus 10. I have added 9 by 4, so I have subtracted 9 by 4. Is it fine?
Yeah.
Okay, now I have completed the square. Now what is 10 minus 9 by 4? 40 minus 9 by 4, 31 by 4, fine.
Yeah.
Now this is a number again from 0 to infinity. So what is this? This is a number from 0 plus 31 by 4. So 31 by 4 to infinity, it doesn't matter if the roots are imaginary or whatever, right? So I can find a range without finding the roots at all. So this is imaginary, certainly imaginary, because this is plus something. Positive, this can never be equal to 0. Correct, you are correct. It's imaginary. But that's not helping us find the range. So to find the range, always do completing the squares. Always see. Am I clear?
Yes, sir.
So if
Got
you
it.
really want to understand what this is, see, what do you mean by imaginary? Can you think of how the graph is? What do you mean by imaginary? You can't draw the graph if it's imaginary.
You can
Is that
draw
what
it
it
It can't be represented in number line.
complex plane.
In complex plane, I can't draw it in the real plane at all. That's what you're saying. I'm asking you.
Yeah,
It's
it
fine.
can't be.
It can be drawn. Then
No, it cannot be.
It cannot be drawn. Just
It cannot be represented in real.
It cannot be. I can't hear you.
Represented in the real plane.
It cannot be drawn in the real plane. That's what you're saying.
Yes.
You're
sir.
breaking up.
Yeah.
Okay. Let me just see your equation. What was the equation? X square minus 3x minus 10 plus 10. Correct. This was the equation. Correct. So
Yeah.
can you simply take points and
1
plot it?
divided by.
Huh? 1. Okay. Forget about 1 divided by. We were analyzing only the denominator, correct? We are not interested in 1 divided by. Forget about 1 divided by. What were you checking? Only the denominator, right? Based on the denominator, you'll find 1 divided by. It's fine. I'm asking, can you draw the graph of this? Can you draw it? That's my question. Are you there? Oh, yeah, you're there. Okay.
Yeah.
Is there a class after this? No, right? So
No.
can you draw the graph of this? Yes or no?
I don't think so.
We can.
You don't think so? Just now we had discussed any quadratic equation is a parabola. That's what you told me, right? You actually can draw the graph. The graph is something like
Yeah.
this. That's all. Any graph, it's a parabola. What do you mean by imaginary roots? It's not that you can't draw it. Only difference is it won't cut x-axis. Okay, this is the graph. This is the graph of any imaginary
Okay.
root. If it cuts axis, what will happen? See, what is x-axis? X-axis is the point where y is 0. Correct. So this graph can never be cutting x-axis because y is never 0. That's all it says. It's not that it is there in the imaginary plane or something. It's a simple parabola. Only difference is it cannot be equal to 0. That's all it says. So it need not be equal to 0 because it's a parabola. It can end at some other point. That's all. Fine. So imaginary can happen. One is this way or this way. There are two types of parabolas. So upwards or downwards. Either way it can be imaginary. Is it fine? So all the parabolas, see, it's like this, or exactly touching. If it's exactly touching, you'll have one root. This will have two roots. This will have no root. No real root, obviously, when I'm talking about no roots. So that's why I said analyzing things in graph is very important. Once you have some kind of picture, right, what it is, so you won't simply by heart it as a figure. So a quadratic equation is a parabola. You don't know what are the roots, how does a parabola behave. So it's better to always see an equation and see what can happen algebraically and what can happen graphically. Right? That will help you analyze it better. Anyways, I think for any quadratic equation, the method would be same. Complete a square, you'll get your answer. Obviously, you have to do much more analysis after that, but the method would be the same. Nothing new, I guess. Fine.
Yes. So, thank you, sir.
Okay. Anything else? I think we can close functions and graphs here. I think next we'll have a test. That's it. So, okay. Thank you, guys. I'll end this session.
Thank you, sir. Bye.
Bye bye.
Thank you, sir. Thank you, sir.